Okay, so we're going to look at question 10, and it's asking us to expand. Well, what does expand mean? Well, expand means that we need to use, I guess, our laws to expand our brackets, and then we need to finally go ahead and simplify if we can. So whenever we're expanding, we're going to do 10a here. We're going to actually get this term, we're going to multiply it by this term. But we can't forget that it's also multiplied by this term as well. All right, that might be easy for just multiplying simple things, but then what do we go ahead and do when we multiply these two together and these two together here? So let's do question A. 7 times 2 is 14, but don't forget, we're not done yet. We're not just adding A. It's actually also 7 as well. So we've got 7A, and we know that they're added together. We've just expanded. Let's go ahead and do B. A times 2B. So first of all, we know that A times B is equal to AB. And 2 times A times B, therefore, is equal to 2AB. But we're not done yet. We don't just add the 6, because it's actually, we've got to have this A times 6 together. What is A times 6? It's not A6, it's 6. We write it as 6A. We always have the number or the constant in the front. So that's going to be equal to plus 6A. Over here, let's go ahead and do 4 times 3A, but remember we've got 2 steps. Now if we were to have, say, 2A times 3 plus 2B plus 6, then we're actually going to have 1, 2, 3 terms, and then we may have to simplify them. Now, let's have a look and go ahead and do this. That's going to be 6A plus 2 times 2 is 4, which is 4AB, and then 2 times A plus B. So it's A times B, which is AB, okay? And then over here we've got 2, so we've got 2AB. Now what we then have to do is collect our like terms. Our like terms, AB, we've got the same 2 variables multiplied by each other. So we can collect those as a like term. And this 6A just has to remain by itself. It doesn't have any buddies. So let's have a look. We've got AB. How many ABs do we have? We've got 6 ABs. And then we've got 6 A's. We can't collect those. So we've now gone ahead and simplified it. So sometimes when we expand, we may have to simplify. So if we had this question that I just made up here, we could simplify it. Over here, though, we've got 4 times 3. So you can always know that, okay, we know what that is. That's 12. A times A. Well, if I were to tell you what's 7 times 7, well, 7 times 7 is 49, but how would we write that in terms of an indices? Well, 7 times 7 is the same as 7 to the power of 2. So the same thing, but if we had A times A, we can write that as A squared. Another thing is, I guess, one of your index laws is that if we have A to the n, any number, times A to the m, I'm not sure if you've covered those yet, but we can simply just add these powers together if we've got the same base. So let's go ahead and do an example of that. A to the power of 3 times A to the power of 2 is equal to A to the power of 5. A to the power of 2 times A to the power of 6. We actually add these powers here. Not A12, it's actually A to the power of 8. So over here, we've got, let me just rub out and make some room for you. It's getting a bit messy. So over here, we've got 4 times 3A is 12, but let's do it on the side. A times A. Well, that's A to the power of 1 times A to the power of 1. We need to, when we have the same base, we add these powers. We add these powers together. You may think you multiply them. 1 times 1 is 1. Well, that's not right. It's A, you add the powers, so that's going to be A squared. So you can do that on the side if you want to. A squared. In maths, you can always do things in stages. I never want to see any of you leaving this space blank. You may not get it all right, but don't leave blank. 4a times 5. So remember, we've got two expressions in the brackets, so we're going to have two expressions. You don't. It's never. A lot of people will just add the 5 to the end. Well, that's wrong because it's 4a times 5, not just the add 5 on the end. 4a times 5. 4 times 5 is 20. And then we have our a. That doesn't go anywhere. And are we multiplying through by a positive or negative? Well, it's just 4a times positive 5. So we know that that's going to be plus 20. Now, we can't simplify that any further. Okay, so that's done. That's done. That's what we've got there. Okay, so question 11. Simplify by expanding and collecting like terms. Now, this is, I guess, the ones which a few people have problems with because it's a a 2 or a 3 or a 4-step problem. So let's go ahead and do that. And just remember that you just have to break it down just like we've done before. It's no more difficult. It's just a few more steps. So let's go ahead and do that. And let's do 11a. Okie dokie. All right. So simplify by expanding and collecting like terms. So let's have a look and break this task down over here. We've got 2, 4 plus a plus 7a. Now forget about this 7a at the end. You know what? Forget about this. Just leave it. Do it at the end. All right. We've got to go ahead and do something to this. We've got to expand these brackets out and then go ahead and simplify if we can. 2 times 4 is 8, and 2 times a is 2a. So we've got 8 plus 2a. We've now done that. Now we can start worrying about what's left over here. Okay, what's left over there is 7a. All right, so have we done yet? No, because this algebraic expression is not happy. He's not happy. Why is he not happy? Because you need to collect the like terms. What are the like terms? Well, we can collect our seed as apples. We've got apples here and apples here. We've got 2 apples and give me another 7 apples. We've got 9 apples. All right, what's left over? This 8, well, we can't really do anything. Okay, it might be 9 apples plus $8. You can't add them and simplify them together. They're two things which are not like, so you can't collect them. We're done there. Okay, so let's go ahead and do question B. All right, it looks daunting because it's a bit longer, but it's really exactly the same process. So 10a times 6. Let's take this over and forget about the rest. 10a times 6. 6 times 10 is 60. The a doesn't go anywhere. 2 times b times 10. 2 times 10 is 20. And a times b is going to be equal to ab. So that's ab. So we've done the left-hand side. This is I guess we'll call this the left-hand side of the equation. Let's just do the right-hand side and then just bring them together. Okay, so the right-hand side, 7 times 2 is 14. So that's 14, but the a doesn't go anywhere. And then it's 7 times ab. We've got 7ab. Now, let's have a look at the signs here, though. This is a positive, and that's multiplying by a negative. Are these the same or different? Well, positive and negative are different. We're always going to have the answer is going to be negative. So the answer to that is 14a minus 7. Yeah, I'll lock it out. Yep, thanks. 14a minus 7ab. Now, we're not done yet because we've got all of these expressions. We don't really need the brackets anymore because we tend to do that when we're multiplying by something. But we've got all of these things that are added together. Let's go ahead and collect like terms. I'll write this out. We've got 60a plus 20ab plus 14a minus 7ab. What do we do here? Well, we go ahead and first of all collect our like terms. We've got the same variable, a, and they're certainly not the same as AB. But these ABs are like. They're alike, and the ones in the red are alike. So we can go ahead and collect them and then add them together. So 60A plus 14A is 74A, and then we've got 20 AB, take away 7, 20 take 7, 13, so it's plus 13AB. Okay, so that's simplified by expanding and collecting like terms. We've just simplified. We can't simplify anymore. We've collected our like terms, that's left over. Now, in terms of this one over here, that's going to be a bit tricky. I'm not sure what level you've learned at year 8, because a lot of these index later. But let's go ahead and do it anyway. I certainly can't spend too long because otherwise this video will go too fast. But let's work away. 2 times 3 is 6, and then a squared times a to the power of 4. Now, we were talking about before, if we have a to the power of m times, and n could be any number, then that is the same as a to the power of m plus n. So we actually add the powers when we multiply at the same base. Okay, a lot of people think we multiply them, we don't. So a to the power a squared times a to the power of 4 is actually a to the power of 4 plus 2, which is a to the power of 6. So we've got left over, we've got 2 times 3 is 6, times a squared times a to the power of 4 is a to the power of 6, plus 11 times 2 is 22, a squared times a is a to the power of 3. Let's go ahead and do the right-hand side, and I might just need to cut this out so I can see it. Okay, so the right-hand side of the equation, the right-hand side, in green, just down here. 3 times 5 is 15, and a times a to the power of 5. Well, the power of a there, a is just a to the power of 1. We add the powers, so that's a to the power of 6 minus 6a to the power of 3. All right, now let's collect our like terms. So it pays to get up your pen and do a circle for 1. So a to the power of 6, we can collect those because they have the same. We have the same base a, and it has the same power. We can't collect an a to the power of 6 and an a to the power of 3. You can't just do that. So we've got a to the power of 3 and a to the power of 3 there. So we can collect those. So when we do those, 6 plus 15 is 21. 21 plus 22 takes 16. We collected those as like terms. 16 a to the power of 3. And we are done there. I know I've gone through this pretty quick, but it's just a matter of pausing, going back where you're stuck. Otherwise, my videos will go forever. But let's go ahead and finish off these questions for the chapter review. We're going to finish off on question 12. Okay, so factorize. Well, what does factorize mean? Factorize means that we can take out a factor. What is the highest thing that goes into 3 and 15? Well, we can take out 3. So if we take out 3, what are we going to have in this bracket in here to give, expand back out to give 3a take 15? 3 times a is going to give us 3a. And what times 3 is 15? 5. We can't really do anything else other than that. To be honest, these won't really make much sense now, because later in year 9 and 10, you're going to do a lot harder questions, and there's a reason for this factorising. At the moment, it probably doesn't seem as though there's much reason to do it. I don't want to confuse you too much, but there's reasons why we factorise. We don't just do it for nothing. Okay? What about here? 20ab plus 16. We've got a constant here and here. So if we want to factorise that, let's think about what number goes in to each of those. 4. Let's take out 4 as a common factor. So therefore, 4 times 5, which is 20, AB plus 4 all we can do. Over here, though, we can't really take out P or Q as a factor. The only thing we can do is take out 5 as a common factor. So 5 outside of minus 3P plus 4Q. There you go. There we have it. That's the factorising done. To be honest, those are not really going to serve you too much use until you get into year 9 and 10. Okay, so I'm going to stop there. Good luck.